The apparently irreconcilable conflict between quantum mechanics and general relativity is used to define a new process. This will provide a consistent view on nature without having to change quantum mechanics or general relativity. Gravity will not be quantized. On the contrary, it is necessary that space-time cannot be in a superposition. This will provide a trigger for measurements independent of observers. The hallmark of quantum mechanics is that a state can evolve unitarily into a superposition. But a superposition of a massive object would also force space-time into a superposition. But a non-quantized spacetime cannot be in a superposition. In the UR process, this tension triggers a measurement when and wherever the superposition of entangled particles will exceed a certain threshold. This immediately solved the cosmological constant problem, since all the vacuum fluctuations present in the unitary evolution cannot contribute to the metric. Only after a triggered measurement, a reduction of the wave function, when one of the superpositions has been selected with quantum mechanical randomness, a back reaction on the non-quantized spacetime metric is possible. This also explains why gravity needs to be so weak, otherwise we would have no substantial unitary evolution between observer-independent triggered reductions. The unitary evolution U and the reduction R in the UR process takes place in U-patches. A U-patch is a part of the entire quantum mechanical state of the universe. The U-patches are independent of each other. A U-patch is an entangled state of its own, consisting of ever more particles, like in decoherence, and forms a product state with the rest of the entire state. The observer-independent triggered reduction immediately solves the measurement problem and explains why there are no huge Schrödinger's cat states. The at first sight paradoxical sounding notion of a observer-independent measurement should now be clear, since it is not the observer or his consciousness that triggers a measurement, but simply the quantum mechanical particles the observer consists of. Also, the wave-particle duality is nothing else but the unitary evolution and the triggered reduction. For example, in a double-slit experiment with a photon or electron, the wave part calculates the probability amplitudes to arrive at some location, and the particle part, the energy momentum, is transferred to the selected location once a reduction is triggered. Regarding our reality as a result of a process of unitary evolution followed by reduction even makes EPR, non-locality, easy to understand. In the UR process, we use the same distant correlation between particles participating in an entangled state to trigger the reduction when the threshold is reached. In the myriads of UR process steps, the unitarity of quantum mechanics is all important, because unitarity guarantees that in each step the probabilities add up to 1 and the energy is conserved. Without quantum mechanics, we would have only deterministic general relativity, where classical matter is just free falling on curving space-time. In the UR process, the rule that classical particles are moving on geodesics is substituted by quantum fields evolving on curved space-time. Classical, larger objects emerge from myriads of U-patches consisting of quantum mechanical particles. A U-patch is evaluated on an intermediary static curved space-time and sets into relation all fields. In the UR process, gravity breaks an exclusively unitary evolution of quantum mechanics, and the quantum mechanical randomness in the reduction breaks the determinism of the block universe. With every triggered measurement, with every reduced U-patch, energy momentum is redistributed and the space-time patches are glued together analog to a sheaf cohomology. The black hole information paradox dissolves, since every UR process step breaks an exclusively unitary evolution. The U-patches map the relational structure that is necessary to explain, for example, the Hawking Unruh temperature for an accelerated versus free-falling observer. The property of general relativity to form black holes and quantum mechanics together made the information of space-time finite, the Bekenstein-Hawking entropy. No need to quantize gravity. Since quantum mechanical randomness is added in every UR process step in the reduction, classical determinism is broken. This breaks the symmetry between the past and the future. This is the real flow of time. The permanent random redistribution of energy momentum in myriads of UR process steps represents statistical mechanics. Now on to dark energy and dark matter. The cosmological constant problem was solved since in the UR process the vacuum fluctuations in the unitary evolution do not, or better, cannot couple to the non-quantized spacetime metric. The cosmological constant lambda is just a free parameter. Thus, the simplest assumption is that lambda is the dark energy. Also, the phenomenon of dark matter can be explained within the UR process without the need for additional unknown matter. This is based on a recent paper by Eric Verlinde. Verlinde's approach and the UR process both are based on information and entropy, are confined by event horizons, and are using thresholds. In Verlinde's approach, the threshold is at the cosmological level when the tension in entropy density falls below a certain value proportional to the acceleration at the de Sitter horizon divided by Newton's constant g. In the UR process, the threshold is the tension in spacetime metric at the Planck level, when it exceeds a certain value proportional to h bar divided by g. The fine-tuning problem. The UR process does not try to explain the exact values of the fundamental constants c, h bar, g, lambda plus 21 from the standard model and maybe 3 neutrino masses, but offers a simple solution to the fine-tuning problem based on a kind of Darwinian evolution of universes. Talking about the fine-tuning problem obviously has an esoteric touch. Another topic with this touch is the many worlds interpretation. Proponents still can find it within every U-patch, but since every U-patch will be reduced, we end up with a single reality in the UR process and not with infinite many worlds. Now to the predictions. Since the UR process just reconciles general relativity and quantum mechanics, there are not many new predictions. One is, since in the UR process the dark energy has nothing to do with vacuum fluctuations, there simply is nothing surprising that the so far predicted theoretical value based on a false assumption is a factor 10 to the power of 124 off the mark. Also, there is nothing surprising that no supersymmetric particles have been found. First, since there are no gravitons in the UR process, there is no need to compensate the fermionic with the bosonic loops via supersymmetry. Second, since the UR process with its triggered reduction comes with a natural cutoff far above the Planck scale also the hierarchy problem is mitigated, where otherwise superpartners or extreme fine-tuning would help. Third, in Berlinde's dark matter approach, there is no need for additional unknown particles, thus no need for additional supersymmetric particles. For these reasons, the UR process predicts there will be no supersymmetric particles found soon. SUSY can be broken at much higher energies. What will refute the UR process? It will be refuted if violations of the equivalence principle will be found, since in the UR process, as in general relativity, gravity is no force like the other three quantum mechanical interactions, but is just curved spacetime. Since the UR process breaks the symmetry between the past and the future, no time travel into the past is possible, meaning whenever you will encounter your older self from the future, then the UR process will be refuted.